All right. So good evening, everyone. Welcome to this session on data science. So if anyone is having any kind of queries till now, and we need to address them, I suggest that you post. There could be some functions that we might not have taken up right now, right? But as we move along, when we take up some real world problems or models, let's say you mailed me, right? Let me just check. Possibly, I think that would be more interesting also. Yeah. I'm going to talk about concatenation, joining, and merging now because I know I was in a hurry yesterday when we closed it. So I'm going to talk about it. Floor is just the rounding down to the nearest integer. Ceiling is, see, it need not be an integer. Floor actually rounds down to a nearest multiple. So if I don't specify anything, that it will round down to the nearest integer. Otherwise, I can also specify the rounding down to a nearest 0.5. Is it? Am I not audible to everyone? Let me just check my connection once again. Okay, then I think Ankit, you have to just check something at your end. Okay, fair enough. So there were a few questions. Filtering data on dates, will take up a use case and we will work on that. Right? Possibly it's the same thing, but we'll have to see dates. I haven't explicitly taken up till now because we have a time series as a class where we will be dealing exclusively with the dates. So I have combined the dates related activities in that time series module that we would be covering possibly slightly later in the course, right? But if required, I'll include something inside. But yeah, floor I have explained. So floor is nothing but we are trying to get the downside. So you have possibly for all these things, you simply explore, okay, what is this np dot floor? NumPy library is going to give you everything. Returns the floor of the input element wise. The floor of a scalar x is the largest. Okay, floor is the largest integer only here, because in Excel we can very well put the floor to the nearest value, nearest multiple. Whereas here it is saying the floor of a scalar x is the largest integer such that I is less than or equal to x. So it is generally denoted as something like this. So, right, so you can very well say whatever is, if you have a decimals and all, by taking a floor, you will round it down to the nearest integer. Similarly, by taking a ceiling, so seal, it will round it up to the next integer. It's the smallest integer such that I greater than or equal to x. So this is like a greatest integer function of x. So you can very well talk about these kind of mechanisms, right? And possibly you look at any function, you will also see, you will also, so you see here the ceiling minus 1.7 became minus 1 because it's the greatest integer. Minus 1.5 became minus 1. Minus 0.2 became 0. 0.2 became 1. So it's a greater one. The next one, that is the next greatest integer. So for 2, it is 2 only because it's the same integer itself. So this is what a ceiling does. and floor does exactly the other side. All right. Then I think there were a few other questions. Yeah, because this is NumPy. NumPy treats all these, I mean, by default, any of these functions, they treat these values as float. And because it treats everything like a float, it typically puts a decimal. So a decimal point is more like it treats as a float. So you can use a 2int kind of function to convert the float into an integer. All right. Then, so there are no other questions, looks like. So I'll just move ahead. Possibly I'll explain first of all the concatenate So typically concatenate is put side by side, no logic, right? It will only match with the row or match with the column. That's it. So you could typically see something here. Let's say here I have created one data frame df1, and so it has 4 columns called ABCD, and there are 4 values called, for A it is A0, A1, A2, A3, for B it is B0, B1, B2, B3, and so on. And the index for these 4 rows is 0, 1, 2, 3. So this is my first data frame. My second data frame is the same. The columns are, so I'm calling it as df2. The columns are ABCD. The values are A4, A5, A6, A7, and so on. The index values are 4, 5, 6, 7. So index values are not 0, 1, 2, 3. The index values are 4, 5, 6, 7. Then there is a third data frame which is having a slightly different set of columns, A, B, C, E. Why is the values using? So we are treating this as a key value pair, right? So for defining my data frame, so A is the name of the column, and I am giving these are the values of A. Okay. So in case of the data frame 3, A is the name of the data, A is the name of the column, and A8, A9, A10, A11. So similarly, I have A, B, C, and E as the columns here. The index is 8. So basically, if you are printing each of these things, df1 will print something like this. Okay, was the disconnection? Did the disconnection happen? I think it will say that the error because it is disconnected. Okay, so I'll rerun this. No, it will still give PD is not defined. So possibly I will have to either, I'll run all what is there. I'll run for the next one also. because we'll have to discuss. So this is the next topic. First, let me finish up the small piece. And I just want to give the approval here for the accessing my Google Drive. Yeah, I'll have to import pandas, but yeah, I simply said let it do because if we have to go back to some other analysis. Okay. So here, did it complete? I think it has already completed everything. So the thing that we are doing is now concatenate. So let's say I want to print only df1. So this is what is printed, right? My index is 0, 1, 2, 3. My columns are A, B, C, D, and these are the values under each one of them. Let's say I'm printing df2. My index values are 4, 5, 6, 7. My columns are A, B, C, D, and these are the values. And df3, my index values are 7, 8, 9, 10, 11. Columns are A, B, C, E. So if they are individually, they are something like this. Now I want to concatenate all these three. So I'm using this PD concatenate and I'm saying df1, df2, df3. So whenever I want to concatenate by default, so then the concatenation happens in this way, right? So possibly what it will take is, it will simply look at the rows, right? So it is appending, it is doing a row appending. That is what happens if I simply do concatenate. So the row numbers will get appended. So I'll get 0, 1, 2, 3 in the first case, 0, 4, 5, 6, 7 in the second case, 8, 9, 10, 11. So the rows keep getting added one below the other. And wherever the column name is matching, under that column, the value will be added. So possibly if we really plan it out, right, your df1 possibly, or we'll see it here itself. So this is my original, this is my df1. My df2 had 4, 5, 6, 7, right? So these are the new rows that are getting created. So row appending is what happens, but it had only 4 columns called A, B, C, D. So it will typically print only up to this. So if I just look at df1 and df2, you will not even get the E column at all. If I simply say concatenate df1 and df2, you will not even get the E column because neither df1 nor df2 has the E column. Whereas when it came to df3, df3 had a E column. So the concatenation simply happens. The E column wise, df1 and df2 will show blank. Whereas under the D column, df3 will show a blank, and this is what is the concat. So it's just an appending that is happening. No rule, nothing. Just an appending. Wherever the headings match, the values go under those headings. Wherever the headings do not match, the values go into a new heading. So that is what is the basic aspect of concatenate with row appending. And this one is a concatenation with column appending. So what will happen? The new columns will get created. In column appending, the new columns will get created. Now, if you see, the first data frame had these 4 columns. The second data frame had these 4 columns. The third data frame had these 4 columns. So like that, the columns keep on getting added. So it's just appending of the columns. Now, wherever the row numbers match, there the values will be utilized. So as we all know here, this is my first data frame. This is what is the second data frame, A4, A5, A6, A7. And this is what is the third data frame, A8, A9, A10, A11 kind of thing. So this is what happens in a column appending. So you have to be very clear on what kind of appending you plan to do. So if you want to do a appending as new columns, then you have to put axis equal to 1. If you want to append as new rows, you can put axis equal to 0. That's one. Then comes the third aspect, right? So one is if you take it as row-based appending and column-based appending. Then the third thing is about joining potentially different row indices. So if we are saying that the index values are different for both the lists, the index values are different. So you are typically joining based on the different row indices. And here we do two things. We can do an inner join or we can do an outer join. So inner join is more like a union between the two sets, and outer join is more like an intersection. So possibly you look at here. So here the left and right matter a lot. We'll see why, right? So possibly I have one data frame here containing 2 columns and 3 rows. The 2 columns are A and B. The rows are the K0, K1, K2. Those are the index values. And I have another data frame which is having 2 columns C and D. And the indexes are K0, K2, K3. So I don't have a K1. So now, first let me do an inner join. So what is that I'm saying? I'll first take the left data. So left data frame. And to that, I will join the right data frame. So I'll first take this one. To this, I will join this one. How do I join? This is an inner join that I'm planning to do. So what happens in an inner join? Just look at it. The first thing is, what are all the common indexes that are there between these two? So K0 and K2 are the 2 common indexes. So I'll simply take only these 2 indexes, K0 and K2, right? Corresponding to these 2 indexes, I would pick up the values of the right data frame. So for the left data frame, yes, A0, A2, B0, B2. And from the right, I will only pick the C and D corresponding to only K0 and K2. That is where it becomes an inner join. Whereas if I go with an outer join, all the indexes will be taken from both the groups. K0, K1, K2, K3 also. All 4 indexes will be taken. And corresponding to all 4 indexes, it will check, okay, A, what are all the values that are available? So whichever is not available, put it as a not available, not a number or not available. Okay. So this is what you could see here. So it will take all, and based on that, it will give the output. Then you could also do a kind of a left join. So in a left join, only the indexes of the first column will be taken, right? And for those indexes only, the new columns from the right will be picked up. New columns from the right will be picked up. So here you remember that the left join is typical. From the left, we are typically picking up the indexes. Possibly if I do a right join, I'll pick up the indexes from the right. Right? K0, K2, K3 are the indexes from the right, and I will join the two columns accordingly. So value to value kind of a merging is what happens here. Then the third scenario or the fourth scenario is merging. Right? Here, there could be some columns that are matching between the two data frames. Now here you have seen the columns are still not matching here. Right? Here the matching is done purely based on the index rows. In joining, the joining typically the joining happens purely based on the index values. So if you may set a different index value altogether, but the joining typically happens purely based on the index values only. Whereas in case of merge, a similar kind of analysis works based on the columns. Based on some columns, you do a kind of a merging of the data. So you see here, I have one data frame containing 4 columns, key 1, key 2, A1, A and B. Right? And I have another data frame which is also containing 2 columns, key 1, key 2, C and D. Right? So key 1 and key 2 are the 2 columns which are common in both the columns. Key 1 and key 2 are common in both the columns. So now what I do in case of merging is I say left and right, and I can here also I can specify inner, outer, left and right. So if I am going with inner, and what is that I am saying on key 1 and key 2 both. So which means, so wherever key 1 and key 2 values are matching here, so K0, 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 K0 is matching. Possibly K0, K1, it's not there here. K0, K1 is not there here. K1, K0 is having 2 instances here. K2, K1 is not having. So what should happen here when you run this? You see 3 instances because K0, K0 is 1 instance. Then K1, K0 here is matching with K1, K0 here. It's also matching with K1, K0 here. So what will happen here when you are merging? This is an inner. So where both the keys are present, in both the data frames, only that much will be taken. So the pair K0, K0 will be taken, and corresponding to that A0, B0, C0, D0 will be displayed. Then similarly K1, K0 pair, the first pair here, K1, K0 will be taken. Then for that A2, B2, C1, D1. This is one. Then similarly K1, K0, here it will be taken, but it will be matched against this one. K1, K0, and it will take C2, D2. Right? A2, B2, C2, D2. So that is what happens in an inner join. Now if you look at for an outer join, all pairs will be taken. K0, 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 K1, K1, K0, K2, K1, K2, K0. And again with each one of them, then with the K1, K0, there are 2 different combinations that are coming. So all those things come up here. You see K0, 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 K1, K1, K0, and with K1, K0, there are 2 instances, and K2, K1, K2, K0. All combinations have come, and wherever the values are applicable, those values are printed, and if they are not applicable, then the NANs are typically printed. So similarly, you can do a left join, you can do a right join, left merge or right merge. Here merging means you are merging based on the column values. Whereas in case of join, you are joining based on the index value. So that's the major difference. Okay, someone was asking, can you please do the inner join once again? For which example? This one? Paridhi? Oh, you're saying inner join, not merge, right? Okay, for merge only. So I'll do it here. Yes. What is your question? So all we are, okay, join. Join is purely based on the index values. So here we have join and merge as two different functions. The join works purely on the index values, whereas the merge works purely on the column value, based on a common column that can exist between the two data frames. Okay. So I think we are done with this basic element. Then I'll move to the next aspect. Okay. So we'll get started with some visualization also. This is also an element of data science. So basically till now, you should be comfortable with all these aspects. The Python basics, Python programming constructs, the data structures, functions, NumPy, pandas. So we will directly move on to data visualization. So basically, there are two major libraries for data visualization. Of course, there are many, but initially you should be comfortable with these two mechanisms. One is the matplotlib, the second one is the cbot. So these are the two libraries that we will be looking at in this particular code block. So I'll be sharing this code block with you, possibly at the end of the session, or I can even do it right now as well. Right now, I'll paste it here. Otherwise, I'll send it via the email or something. Okay. So now we are, but of course, I'll be making some small changes also for the session. So we'll talk about matplotlib, which is actually a very good alternative to licensed tools like MATLAB or some other kind of graphing tools, etc. Possibly, I mean, it has a lot of dynamicness and it really does a good job in plotting a lot of graphs. So we'll talk about the basics and we'll try to do some kind of basic charts, bar plots, histograms, box plots, scatter plots, etc. Then we'll also use the Cbon, which is actually built on the top of matplotlib only. But the advantage is for some very common routine kind of charts, just with one line of code, you can very well generate a beautiful chart. So if you don't want to bring in too much of customization into your chart, you want to use the default implementation of the chart, then possibly the Seaborn can also give you some good visualizations as such. So we'll talk about how do I customize the plot. So this data visualization is one of the important components in data science, because possibly you would understand the various patterns in the data through this data visualization aspect. So obviously, this is a key step in data science, data visualization. And because we are working with Python, we are trying to look at some of the libraries that are really helpful in Python. So data visualization is a very important skill for data scientists. And this really helps you to interpret the data easily in an effective manner. That's the major intention behind data visualization. So obviously, you'll get a very good grasp of the data, and communicating the results of your analysis is quite comfortable. So now let's see why I'm choosing what is matplotlib. Just like the way we have explored NumPy and pandas, matplotlib is another such kind of a library which is very popular. Most popular data visualization library with Python. So it produces a lot of quality figures, and you can very well save them as different formats, or sometimes you can simply print them as well. So possibly a matplotlib produces a lot many such kind of figures. And obviously the impact of any data visualization is the numbers which cannot be comprehended easily if they are in the raw number form, they can get better comprehended and understood using matplotlib. So you can generate so many kinds of charts, right? Possibly if you know some basics, then after that, as we have seen, the help file of that particular library will typically help you to do the necessary plotting. And the good thing is, it can very well work with both NumPy as well as pandas. So you can very well give array as an input, or you can give data frame as an input. So that's one more additional advantage, right? The functions are compatible both with NumPy as well as pandas. And it's a very good open source alternative for paid softwares like MATLAB for doing a lot of graphical modeling of the data. So if I have to work with MATLAB, there are three important points that we need to focus on, right? One is, where do I produce the plot? So what is the figure size? What is the length and width of the area where I'm doing the plotting? Then comes the axis. So what is to be taken on the x-axis and what needs to be taken on the y-axis? And then I'm simply presenting the data. So that's it. So you could see here, how do I start out if I have to start out with matplotlib? So you can simply say import matplotlib, or so matplotlib is a slightly bigger library. So this matplotlib library, so you can very well refer to different, how do I get different kinds of plots, etc. Right? And the API reference. So you could see here, you could do a lot of animation on matplotlib. It's a very huge library. So that's where what we say is within this so rather if you import matplotlib, the memory consumption could be much larger, because I don't require everything from matplotlib, because you see there are so many aspects of matplotlib that we will not be using also. So rather than importing the entire matplotlib and eating up the memory, sometimes what we suggest is go to the next level. So matplotlib dot pyplot. Pyplot is what is typically the Python based plotting. So what we are simply saying here is from matplotlib, only import pyplot. Don't import all the others, because most of my this thing will come from pyplot. So from matplotlib.pyplot, so from matplotlib, import the pyplot. Or you can very well say import matplotlib, but importing matplotlib will actually consume a lot of memory. So sometimes I can very well say only import pyplot, don't import the entire matplotlib. But of course, if I require many, then I would simply say import matplotlib itself. So, or sometimes we may write import matplotlib.pyplot as PLT. So even that kind of a mechanism can be done. And of course, because we will be using NumPy and Pandas, we are importing them as well. Then we can also say this matplotlib charts, the charts that are generated by matplotlib, you can say that they can be displayed inline. Inline means just here itself. Because this entire notebook I can save and I can simply analyze it. So it contains the code, it also contains the output. All of them are packaged together. Okay. So let me simply start off here. I want to create a simple chart. Right. So here the chart that I want to create is a kind of line chart. So if I want to create a kind of a line chart, let's say I'm taking a simple data, right? I'm defining a function to create a line chart, wherein the x values, I'm just taking values from 0 to 9, np.arrange. So I'm using the numpy array here. Arrange 10 is the values are taken from 0 to 9. So you have to be slowly comfortable with the usage of function. Even if you are not able to write them on your own, you should be able to understand all the functions, or you should be able to Google out and see what this function is doing. So slowly you will keep learning. And I'm taking the y values as x square. So I'm simply plotting y equal to x square. By doing this, I'm simply doing the plot for y equal to x square. So what do? I said we need 3 steps. One is the canvas to draw the data. So what is the kind of graph that I'm interested in plotting? So plt.plot will give me. Now, how do I know this? Okay. So you simply say plt dot. So you will see there are different kinds of, you see a lot of values are there. Possibly if you may have to get into each one of them. So some are more and more to do with the beautification of the chart, but plot is like a line chart. Plot, if you really see what it is, plot y versus x as lines and are markers. So it is saying you can plot between x and y as a simple line chart, right? So you could clearly see here, you can say plot x comma y, then it would typically take a line style and color, the default. Or you can very well say BO. So B is a blue color, O is like a circle. And if I simply say plot Y, it will only plot the Y. And possibly if I say R plus, it will take a red color and put kind of plus. So there is a lot of customization that you can do. So you could say here GO minus minus. right? So you can try all these kinds of combinations. The help file typically gives you all the various possibilities. So the markers can very well come out with this kind of representation. So let's see here in this function, I'm simply plotting the X and Y. I'm putting a title to the canvas by using plt.title. I'm using an X label. I'm using a Y label. After I do all these things, I'm simply saying show. So this entire thing is as a part of this function called create sample chart. So possibly if you say create, let me first run this and I say create sample chart, you see the graph is plotted. And if I say create, so possibly here in terms of plot series, I go with let's say KO, black color. Now you see K stands for black. So there are some specified notations for different colors. R stands for red. So, and when I put the marker after the name of the color, then possibly only the markers will be displayed. So possibly if I say R plus in red color, the plus symbols will be denoted, right? And so like that, there are multiple notations for the same. And if I just put R, a red colored line will come. So like this, you can very well keep changing some of the attributes and you can get the plot. So this is like a very basic plot and this is a line plot. So you can say when you are using this function called PLOT, you are actually generating either a line plot or a marker plot. Okay. Okay, PLT is nothing but we have imported pyplot, right? So we have imported pyplot. So in the pyplot, so this is what is matplotlib.pyplot. So within this pyplot, all these plotting commands are there. ACOR, plot the auto correlation. In time series, we would be looking at this ACOR, which is the auto correlation, right? Or possibly I can look at the definition of the axis. So if I say bar, I'll plot a bar plot, right? And if I say box, it will plot a box plot, or possibly box plot, it will draw a box and whisker plot. So like that, if I'm saying PLOT, so you could see different kinds of plots can be plotted here, right? If I'm saying PLOT, it's a Y versus X lines are markers. So that is what is the PLOT doing. Is that okay? I don't know where asked. Naveen Sen, I think you have asked it. What is plot.show? So till that time, the showing of the plot will not happen, right? It has already written as a part of the function, right? So this is all saving internally, but the plot is not getting displayed. If I don't put, it does not display the chart. It has internally a plot object was created, and to that plot object, the X and Y values are added. The red color is added, the title is added, the X label is added, the Y label is added, but it is not displayed. Only the show function will actually display the plot. Okay. Then what value does X take from 0 to 10? What value does X take from 0 to 10? So you see, it is taking all the values from 0 to 9, right? Because we have given a range. A range of 10 is what is typically taking the values from 0 to 9. So X we have defined as taking the values from 0 to 9. Okay. Now the same thing, let's say, what if we want to increase the X-axis? So you change the numbers here. So possibly instead of A range 50. So sometimes what can happen is you can very well treat those things as a part of your parameters also. Right? In the function, you can give as parameters. So now you can see that this is what is happening. Right? We'll also talk about the figure size. So some of the additional attributes also. So we'll talk about those additional attributes as well. Is PLT unique or we can use any name? That's again just like NP for NumPy and PD for pandas. For PyPlot, PLT is the most commonly used one. But you can use anything. Right? But it's just like a NumPy and pandas. I think people became very much used to plt.plot, plt.title. So if you use some other word, possibly it might not go well with the most common users of Python. So I would always suggest go with PLT, right? And similarly, when we go with C1, it is SNS. We'll talk about that. Right? These are very common terminology because people have almost got addicted to those terminology. Okay. Now, let's say I want to create a sine graph. Now the same thing, everything. Now here I'm just changing the A range. Create a graph for y equal to sine x. X value should be from 0 to 10, incrementing in steps of 1. So this is how you will define the A range now. And np.sine. So we are taking the sine value. All other things we are keeping it the same. So just look at this part. If something is not clear to you, just let me know, we'll discuss it. So we'll get the sine chart. I'm just showcasing the same. So any query on this, we'll discuss. Of course, a lot of things can be externalized, right? So I can very well, now I'll show the externalization. Minval equal to 0, maxval is equal to 10, right? Then I'll say X series is a range from minval to maxval in increment of 0.01. So what could happen here? The code for the function will still remain like this. And if I don't give anything in the parameters, it will take the default parameters of 0 and 10 and it will give the same chart. But here, if I say 5 to 25, it will plot a different plot. Right? It will start from 5 and it will go to 25. So sometimes the externalizing of the parameters is also a very, I mean, especially when you are creating the function, you visualize what all parameters you need to externalize. right here, then you don't need to change every time in the code, or possibly we can also add increment is equal to 0.1, and here you bring this, instead of 0.1 you bring increment here, right? So possibly now let's say instead of 0.1 as an increment, I want a 0.5 as an increment. Now my chart may come slightly different because it plots for 5 different number of elements in data. So obviously, if we have different, so you want to say multiple charts, right? Yeah, just wait for some time. So you are referring to, so that's, I mean, unstructured is slightly a different usage there, but you are primarily referring to different number of elements in the data. So possibly one chart may contain only 50 elements, the other chart contains 70 elements, and so on, right? And possibly different columns may have to be plotted. So there could be different requirements. So you are asking for multiple charts to be plotted. So just wait for some time. I have the subplots. I have the concept of subplots. I have multiple plots also. So just hold on for some time. Okay. So we have created the center. Now we will again work with that. So that's the basic. So basic wise, so we know now. Now we will start working with some basic charts to start with. And after that, again, you can go ahead and do your exploration. What kind of charts? So you can very well open up this one. And in this, you can see. So that's where what I suggest, as I have told last time also, like you can work on your own data set, or possibly if you want me to give some data sets, I'll give you the data sets. You can work on your own data sets as well. The intention typically is try to replicate all the functions that we are trying to do, and possibly some more additional functions, right? In all the aspects. Now, let's say if we are doing a data visualization, try to take some data set, try to use as many functions as possible, right? And try to beautify your data set. So if more and more interesting outcomes, interesting analysis, or interesting visualizations come out, possibly we can very well take them to the Actuary India magazine as well. At least one or two or three, the most appropriate visualizations, the most appropriate modeling aspects, we can very well take them to the Actuary India magazine as well. So anyone would like to take up some of these data sets, possibly again not present. It would be better if you can pick up some data set from the BFSI sector itself, and more preferably some insurance kind of a data set, because the target audience generally are more and more from the insurance industry, though the other risk segments also are there. So if you can typically take some data set relating to insurance, or with respect to even the financial services or banking, and then produce such kind of data visualizations. Some of them, whatever we are discussing, but some of them, you know, now these are the kinds of charts that are allowed in Matplotlib. So you can try to use different kinds of plots and then see, right? And finally, I can very well do a kind of saving the figure as well. So I can very well do the save figure also with a specific name. Okay, so right now I'll not get into that aspect, but you could see there are different such kind of functions that are there, right? So let me come back. Now we are reading our data file again, the same data file, which was our loan default data. Now I want to visualize that data. We are loading this loan default data. I want to visualize the data. So I'm simply, first of all, printing the head, the top 5 values. And of course, to avoid dot, dot, dot in the column name, I simply said display maximum columns as 1000, or sometimes we have done it as none as well. So with that, possibly you can very well get maximum number of columns, 1000 columns, or unlimited number of columns, and it will not show a kind of a dot, dot, dot for you. Now I'm making a small change to the data. Yesterday we have seen that the year column contained only one column, one value, 2019. So that's where here temporarily I'm making a small change. So the first 10,000 observations for the year column, I am making it as 2016. First 10,000 observations, I am making it as 2016. Then the 10,000 first observation to the 30,000 observations, I am making it as 2017. And 30,001 to 60,000, I'm making it as 2018. And the remaining ones, I am keeping it as 2019. Just that I wanted to use a line chart. So because I wanted to use it, and in this data, I am not able to see that kind of a date element or a year related or time related element, I simply have just modified the data a little bit so that our learning can be done with one single data set itself. Okay, so this is the change I have done. So what I want to see first, how in the parameters, it will take the default parameters of 0 and 10 and it will give the same chart. But here, if I say 5 to 25, it will plot a different plot. Right? It will start from 5 and it will go to 25. So sometimes the externalizing of the parameters is also a very, I mean, especially when you are creating the function, you visualize what all parameters you need to externalize. Right here, then you don't need to change every time in the code, or possibly we can also add increment is equal to 0.1. And here you bring this, instead of 0.1, you bring increment here. Right? So possibly now, let's say instead of 0.1 as an increment, I want a 0.5 as an increment. Now my chart may come slightly different, because it plots for 5, 5.5, 6, 6.5, and so on. It does not plot for the intermediate value. So you can very well create your own customized charts. First, you have to specify the name of the plot. That is what is like canvas. We are loading the plot area into the memory. So I want a, so what we are saying here is I want a line plot. And I would say that this is the title, this is the x-axis, this is the y-axis label. And after that, the whole plot will be shown. Okay, let me see. There was a question. How to create more than one graph for unstructured? Just wait for some time. I think we'll have the answer. What is that unstructured data? I mean, I just wanted to know if you are using the name unstructured data in the right context. So that's where I was trying to ask the question. If you are clear on the definition of the unstructured data, fair enough. So I just wanted to understand if Archana's understanding is also the same. Yeah, Paras has mentioned it fine. So any data that is not in a tabular format and not convertible into a tabular format directly. Now CSV is also not tabular. It's a comma separated value, but it can be converted into a tabular. Then we still call it as a structured data. Different number of elements in data. So obviously, if we have different, so you want to say multiple charts, right? Yeah, just wait for some time. So you are referring to, so that's, I mean, unstructured is slightly a different usage there, but you are primarily referring to different number of elements in the data. So possibly one chart may contain only 50 elements, the other chart contains 70 elements and so on, right? And possibly different columns may have to be plotted. So there could be different requirement. So you are asking for multiple charts to be plotted. So just wait for some time. I have the subplots. I have the concept of subplots. I have multiple plots also. So just hold on for some time. Okay. So we have created the center. Now we will again work with our, so that's the basic. So basic wise, so we know now. Now we will start working with some basic charts to start with. And after that, again, you can go ahead and do your exploration. What kind of charts? So you can very well open up this one. And in this, you can see. So that's where what I suggest, as I have told last time also, like you can work on your own data set, or possibly if you want me to give some data sets, I'll give you the data sets. You can work on your own data sets as well. The intention typically is try to replicate all the functions that we are trying to do, and possibly some more additional functions, right? In all the aspects. Now, let's say if we are doing a data visualization, try to take some data set, try to use as many functions as possible, right? And try to beautify your data set. So if more and more interesting outcomes, interesting analysis or interesting visualizations come out, possibly we can very well take them to the Actuary India magazine as well. At least one or two or three, the most appropriate visualizations, the most appropriate modeling aspects, we can very well take them to the Actuary India magazine as well. So anyone would like to take up some of these data sets, possibly again, not present. It would be better if you can pick up some data set from the BFSI sector itself, and more preferably some insurance kind of a data set, because the target audience generally are more and more from the insurance industry, though the other risk segments also are there. So if you can typically take some data set relating to insurance, or with respect to even the financial services or banking, and then produce such kind of data visualizations. Some of them, whatever we are discussing, but some of them, you know, now these are the kinds of charts that are allowed in Matplotlib. So you can try to use different kinds of plots and then see, right? And finally, I can very well do a kind of saving the figure as well. So I can very well do the save figure also with a specific name. Okay, so right now I'll not get into that aspect, but you could see there are different such kind of functions that are there, right? So let me come back. Now we are reading our data file again, the same data file, which was our loan default data. Now I want to visualize that data. We are loading this loan default data. I want to visualize the data. So I'm simply, first of all, printing the head, the top 5 values. And of course, to avoid dot, dot, dot in the column name, I simply said display maximum columns as 1000, or sometimes we have done it as none as well. So with that, possibly you can very well get maximum number of columns, 1000 columns, or unlimited number of columns, and it will not show a kind of a dot 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 for you. Now I'm making a small change to the data. Yesterday we have seen that the year column contained only one column, one value, 2019. So that's where here temporarily I'm making a small change. So the first 10,000 observations for the year column, I am making it as 2016. First 10,000 observations, I am making it as 2016. Then the 10,000 first observation to the 30,000 observations, I am making it as 2017. And 30,001 to 60,000, I'm making it as 2018. And the remaining ones, I'm keeping it as 2019. Just that I wanted to use a line chart. So because I wanted to use it, and in this data, I'm not able to see that kind of a date element or a year related or time related element, I simply have just modified the data a little bit so that our learning can be done with one single data set itself. Okay, so this is the change I have done. So what I want to see first, how did the loan amount vary among the years? So wherever you have a time related element on one of the axes, that is where we generally prefer a line chart. Though you can very well use it, especially when X and Y are very much related, right? Like in the earlier case, Y equal to X squared. In that case also, we can very well find out what is the, in the Y equal to X squared, we can also do a line plot, right? But most commonly what we see is the line chart is more and more common when one of the variables is typically a time related variable. That is where a typical line chart is very, very common. We need, so we have to compare among the years, we need one value for each year. So possibly I can take it as a mean loan amount or a median loan amount or something. So once I take the loan amount, sorry, the year on the x-axis and the mean loan amount or the median loan amount for that particular year on the y-axis, and then I display the plot. So simply you could see here, I have created the data, and we have simply got, let me remove this. So it has simply given that for 16, 17, 18, 19, these are the 4 years that are there in the data, because we are saying group by data. So if you remember, we used the group by earlier. Group by will split the table into multiple subtables. And for each subtable, it will compute the mean separately for all the numerical columns. So you could see for loan amount, the mean value is computed. The rate of interest, the mean value is computed year-wise. Interest rate spreads and so on. So now when I want to plot, I require as an X series, I want just the years. And I know the years are nothing but the index now. Index for this new data frame are the years. And possibly the Y is the mean loan amount. So I can very well take means of any of them because all the means are computed here. So I took that, and now I can simply plot. So when you are using the word PLOT, it is more like a line chart or just a marker chart. So you can very well say you give the X series and Y series. And after that, you give the title, X label, Y label, and finally you say show. So this is what I got. So possibly it looks like in 2016, the mean loan amount was much higher compared to 2017, and again it fell down in 2018, and possibly it increased into, but of course, let's remember the 16, 17, 18, 19 were dummy numbers that I have created, right? All the data was, in reality, all the data corresponded to 2019, but just to observe something, as a random thing, first 10,000 I created as 2016, then some 20,000 to 2017, and so on. So basically, so that is where I can very well use the line chart. So line chart is primarily when there is a time related element, and I am typically comparing the time related values across. Then I also possibly are quickly looking at, so the chart was a line chart. We are not now going to look at possibly the bar plots, histograms, box plot, scatter plot. I hope all of you know these charts very well, right? So quickly to run through. So generally the bar plot, again, I don't want you to plot the wrong plots for a particular data, right? Sometimes when you actually work with Excel, to bring a lot of diversity into your plots, I have seen a lot of people trying out different plots for the same data. In reality, that does not make sense from an interpretation perspective because each chart has a different purpose altogether, right? So from that perspective, so this box bar plot is primarily when you are trying to plot for categories. You have different categories of data and you want to group the data based on that category, and you want to present a metric corresponding to that particular category. In that case, a bar plot is much better, right? So you could clearly say it's a rectangular bar. So it does not have a linkage with the previous value. So when you are having, see, typically I have seen people doing this also. Let's say I have male, female, joint, something. Male is the account holder, female is the account holder, joint account. And possibly I say loan of 30 lakhs is the 32 lakhs, 34 lakhs. Let's say for male, it is somewhere here. For female, it is somewhere here. And for joint, somewhere here. So you cannot do this graph. This graph is a very wrong graph, right? So it's always better to have this graph. It's always better to have this graph here. Not because there is no relationship, there is no linkage between these two values. What does this value represent? What does this value represent? Someone between a female and a joint. Is that the loan amount? It does not mean anything, right? So wherever there is no meaning to the in-between value, better do not represent it as a line. Always use a bar chart in those kind of cases, right? So you can have both horizontal bar chart or even a vertical bar chart. It shows the relationship between a numerical variable and a categorical variable. So you could see here. So the categorical variable is gender, male, female, and joint. Numerical variable is like average loan amount. Average loan amount across males, for females, for joint account holders. So it can also talk about changes in data over time. So possibly there you treat the year. So even year I could have considered, right? But that year I can very well take it in the bar plot also. Then it does not showcase any kind of a trend or anything. I should not use it for trend analysis if I am putting it in the form of bar chart. But if I am putting it in the form of line chart, I can very well look at the trend. So you could see here line charts are useful for small changes in a trend over a time. Whereas when we are doing for a bar chart, possibly you can take discrete time intervals. And for the like year on year, I can very well see how big a kind of a change. But if it is more continuous, it's better that I go with a line plot. And different groups and all, it's always different categories, different groups. It's always better to go with a bar chart. And of course, we have different kinds, vertical, horizontal, and stacked. Stacked is one bar over the other. The only difference is now you use PLT dot bar. Everything else can remain the same. I can simply use PLT dot bar. Right? So now, let's say I want to plot a bar chart. Possibly, I can even create it as a kind of an external variable as well. Right? So I can very well go with a data. So if I say bar plot of X, so I have to give what is this X, right? So I will have to specify, I'll have to talk about bar plot of X. And in this XR, possibly you should, right now here, let's not bother much about it. You can think about it. So let's say I want to do the plotting for the gender. So I'll have to specify the name of the data frame, right? So possibly I'll say, otherwise the name of the data frame, X is the name of the data frame, or I'll say DF, comma, I'll also require the gender, which is like a column. So these are the two parameters that I want to pass, the name of the DF, and I would also require the name of the column to be passed. So possibly what will happen here, so the variable that I want to plot is nothing but I'll take the DF, I'll group by DF dollar DF dot call1. I'll group by DF dot call1. I'll take the mean. I'll take the plot of, so I'll take a plot dot bar to talk about the index of this. And also, okay, I'll have to do the call1 and call2 also. So possibly. So here I'll say, instead of this, I'll have to say call2. So this is what is like an externalizing, right? Or possibly here also, I'll put it like call1. Now the title wise, I will put, right? So the call2 plus by call1. Let us see. We'll try to generalize it. X label, you simply call it as call1. Y label, you call it as mean of call2, right? And possibly here, Let us see whether this comes or some kind of modifications are required. Okay. Oh, okay. Bar plot, I have to give now three inputs. One is the name of the data frame. So our data frame is typically called default underscore df. That is the name of the data frame. Then the column that I am considering, the call one typically is the group by. So I'll use the column called gender. Column one, I'm calling it as gender. And column two, I will call it as loan amount. So I'm externalizing it rather than modifying the whole function every time. I can simply modify this one. Let us see now. Yeah, looks like it has plotted. So it has taken loan amount by gender, mean of loan amount, the gender is here. So it has done. Now let's say if I want to do let's say another gender based loan to value ratio or gender based property value. Right, just change it here and I'll get a different bar plot altogether. So this is the property value mean. Right, possibly I can also say some other the function also. So this is like you should be very comfortable with doing these kind of externalizations also, right? Sometimes you can make the changes within the function, right? And sometimes you can simply give a parameter within the function and externalize that so that people actually use the parameters every time uh, and they can plot many graphs comfortably. Okay, let me just see some of the questions that have come out. Please suggest a book. I think I have already suggested one. Right, that's a very good book. Possibly your friends can share with that. Someone has actually shared the soft copy of that book also. Right, data science from scratch. So you can very well refer to that book where you may get some more kind of models also, and some of the things that some of the concepts that I have picked up also, they come from that book as well. From where we can get do's and don'ts for effective visualization. I think relating to that, it's always better to Google out because Google contains a lot of information. Or there is one good book, storytelling. I don't remember the name of the book. Storytelling with data. There is a good book called Storytelling with Data, and there's something more after that. But that's a good book. Possibly that talks about the good and bad of visualization. But some of the basic concepts we tried to cover here. But yes, yeah, if you want from a more detailed perspective, it's always better to refer to those kind of books, which are they only talk about, they don't talk about models. They talk about the philosophy behind data visualization. So possibly sometimes reading that kind of a book also might help. Then when you are talking about the X ticks, these are the ticks that you see on the x-axis, right? So so that is where, so relating to the index values is what I'm asking it to plot. And at a the text has to be plotted at a rotation of 45 degrees. So possibly if you say a rotation of 90 degrees, this is how the text will come. Right, so the ticks are talking about so possibly a quick thing is always go back here. So any doubt you get, you open this library, or you can actually put your cursor there. But sometimes this is more easier because you'll get a much more detail. Get or set the current tick location and the labels of the x-axis. So the current tick location I can very well set. So wherever the index is, I'm saying set it at that particular index. So the index is 0, 1, 2, 3, right? So you set it at that location of 0, 1, 2, 3. Let the tick be there. And you can also specify the rotation of the what you call rotation of the label, which you can very well set it to whatever angle you want. So if you put it as 0, then it will show it as like a horizontal text, just like that. Then similarly, the third kind of a graph that we can look at is the histogram. So possibly people sometimes get confused between histogram and the bar plot, because both of them may look one and the same. The only difference between them is in case of bar plot, you will find a gap between the two charts, two bars, because this is about the categorical data and discrete observation. Whereas in case of histogram, the x-axis is like a continuous data. It's a numerical value. It's not a categorical value, right? So the numerical value is actually divided into some buckets, and corresponding to each bucket, the values are typically plotted. So because of that reason, we will see that you will not find such kind of wide gaps between the bars in a histogram. So bars to show the frequency of the data items in successive numerical intervals of equal size. So you will not, so they are successive values. You will not find a gap in a histogram between the bars. But otherwise, you can plot the histogram as a vertical bars or a horizontal bars. And you can plot a histogram only for a numerical variable as an input. Whereas in a bar, we said it's a relationship between one categorical variable and one numerical variable. Whereas in case of a histogram, it has only one numerical variable as the input. And the primary purpose is to understand the distribution. So the entire range of values are divided into some groups, and for each group, the frequency is typically being measured. So that group is actually called as the bin. Each one is called as a bin. So generally, you will find the bars are of equal width, but in some cases, you can very well talk about merging a few classes. Even those kind of things can be thought of. And especially when you are using large data, you want to understand the distribution of the data primarily. The main purpose is the distribution of the data. So you want to understand primarily the distribution of the data, you can very well rely on the histogram, right? And sometimes even the abnormal values and the outliers also can very well be identified through the histogram. If there are any abnormal values and all, you can very well go them through the histogram. And it is the area of the bar that indicates the frequency. So these are some of the important concepts. Now let's say we generate one sample histogram, and after that we'll try to develop the histogram from our data as well. So you take the data from 0 to 10 with some interval of 0.1. So we have so many x values. For each x, I wrote some dummy function, x minus 3 whole cube minus 1000 plus some random value. So I'm using rand int. If you remember, it generates a random integer value between these two numbers, minus 20 to plus 20. It will generate some random integer number. And like that, it will generate whatever is my X. So those many values are typically generated. Now for that, I'm simply doing a plotting of the histogram, and so when I simply say plot, it will only load, it will not display. Only when I use plot plt.show, then only the plot is displayed to me. So this is how the histogram comes. It looks like a very attached kind of figure. The detached figures do not exist in a histogram. So possibly if you really want to know the loan amount, I can very well create a histogram. So the same thing, but right now I will not externalize, but I have already shown how to externalize a particular variables, particular parameters, how to create a function with parameters, and possibly take those parameters externally, and based on that do the plotting. I have already discussed that aspect. Probably you should try those things, and based on that we can take it further. So the histogram plot, so we have taken the loan amount as one variable called y1, and I am trying to plot the histogram with 100 bins. 100 bins means 100 different 100 blocks is what it is dividing. Now what is that I can interpret? You see, my whole data is ranging from 0 to 3.5. And what I could clear, because I wanted bins, right? So what will happen when I say 100 bins? What will happen is the minimum value and the maximum value will be taken, right? And that entire data will be broken down into 100 intervals. So that whole data will be broken down into 100 intervals. And for each interval, the count of the number of observations is typically taken. That is what is a typical histogram plot. All right. So you could see that major concentration of the loan amount has been between 0 to 1, not even 1, slightly less than 1. After that, I rarely see, but there are values, otherwise it would not have given like this. There are values, but those variables, but those values are very, very small in frequency that I am not able to visualize them here anyway. So that means those could be very well treated as outliers in the model. Bin is okay. Let's say I have the minimum data is, it's like class intervals. I have a minimum data as 10 and I have a maximum data as 50. And let's say I say the bin says 5. So what would typically happen is, now because the bin is 5, the bin width will be computed as 50 minus 10 by 5, or possibly if I say minimum value is 0 for simplicity, or possibly even let it be 10. 50 minus 10 by 5, so which is like 8. So what will happen? 10 to 18 will be one interval, right? Possibly 18 to 26 will be another interval, 26 to 34, 34 to 42, and 42 to 50, right? So the only difference is the 18 minus. So 18 would not, actual value of 18 would not be counted into this group. Here. So 18 will be counted here, but here 26 will not be counted. Right? So, or you can very well create it the other way as well. So the default behavior is 18 will not be counted into this group. 18 will be counted into the next group. 26 will not be counted in this group. 26 will be counted into the next group. So like this, you can very well create the bin width. And based on that, you can say how many observations are there between 10 and 18, how many are between 18 and 26, and so on. So that is what is the bins and the bin width. All right. Then we are moving on to the next plot, which is a box plot. Obviously, many of you might be aware of it in some form or the other, but probably there is an important consequence of that. It's a very, very important graph to identify the outliers present in your data. So normally the graph box plot actually gives you many values. It gives you the minimum, it gives you the maximum, it gives you the median, it gives you the first quartile, and it also gives you the third quartile. So these are the 5 values that are very much presented. And in some cases, it also are in wherever applicable, it also gives you some kind of outlier values also. So this data, possibly I'm giving some kind of explanation. I think this I have just copied from the book as well. So depicting the groups of numerical data through their quartile. So you have the first quartile, you have the second quartile, which is the median, and the third quartile. Box plot is a standardized way of displaying the distribution of the data, right? We are saying the distribution of the data. Do we have outliers, right? How much is the data skewed towards the left or skewed towards the right? We can see all those things from the box plot. The primary values that are computed from the box plot and that are plotted in one single box plot is 5 observations. The minimum, the first quartile, the median or the second quartile, the third quartile, and the maximum. And the simplest box plot displays the full range of variation. So basically from the box plot, you can understand what is the range of the data, minimum to maximum. What is the range in which the data is lying? That's something that you will get. What is the likely range of variation? Generally, this is a very important thing. I know, I hope some of you might be knowing it. So the likely range of variation on a broad note, we try to assess the broad range of variation from only the interquartile range, which is typically the difference between the Q3 and Q1. What we are saying is only the typical middle 50% of the data, right? Q3 and Q1 typically contribute to the middle 50% of the data. The middle 50% of the data, they contribute. What is the kind of variation that we see in the middle 50% of the data? And even the median value, which is typically a central tendency, even that has been typically seen. So not uncommonly, real data sets will display surprisingly high maximums or surprisingly low minimums, and they are called outliers. Sometimes we would also see that the maximum and minimum that is displayed in the box plot is actually not the maximum and the minimum, but the allowable, the maximum limit and the minimum limit, not the maximum value and the minimum value. So it would typically specify maximum limit and the minimum limit. And beyond those limits, they are typically called as outliers. So outliers wise, this is one mechanism to identify the outliers in the data. So even if you understand from a typical theoretical perspective, there are 2 basic mechanisms of identifying the outliers in the data. One is you simply say, I mean, especially when you are using the box plot or when you are using the interquartile range, what is said is you take Q1, Q3, And of course, IQR interquartile range is Q3 minus Q1. What it suggests is you take a value Q1 minus 3 times the interquartile range, Q1 plus 3 times the interquartile, Q3 plus 3 times the interquartile range. So if the values cross this, if your values cross this, it's a definite outlier. These are called definite outliers. But rather, if it is just 1.5 interquartile range, below the 1.5 interquartile range, or above the 1.5 interquartile range from Q3, you can very well call them as suspicious outliers. So possibly it's like these are the starting point of the outliers. So you may not want to take them so seriously, but still they are not, they are deviating a lot. They are deviating from the rest of the observation. But when we are saying 3 IQR outside the Q1 and Q3, then we are considering them as serious outliers, and possibly some kind of handling of those outliers is very much required. So that is what I am saying here. Outliers are either 3 interquartile ranges or more above the third quartile, or 3 IQR or more below the first quartile. That's like a guaranteed kind of an outlier. So you need to have some mechanism to address those outliers. And the second one is like a suspected outlier. So as we have already talked about, 1.5 times the interquartile range or more above the third quartile, or 1.5 interquartile range below the first quartile. So it also plots the median, the interquartile range, the upper quantile, the lower quantile, and the whiskers. Whiskers are nothing but the limits I told about, right? The maximum limit and the minimum limit. So whichever. So I would also look at like the boundary outside the box. The box is typically the middle 50% of the observation, Q3 and Q1. So outside the box, we'll have a typical line, and outside the line, we'll have a typical horizontal line. That horizontal line is always a kind of a whisker, right? So you could see here, possibly if I am doing a simple box plot of taking the values from 0 to 9, and I'm just doing the exponential value of that. So you could see that this is how the box plot has come out, right? You are seeing a box, the lower value and the upper value, and this is the whisker on the higher side, but I'm not able to see the whisker on the lower side because the Q1 and below the Q1, I'm seeing the values are almost submerged, right? So we can, even in our example, we can very well do the box plot. We could see here, the red line is like a median, whatever is the colored line is the median. So this is like a Q3, this is like a Q1. And we are talking about the limits on the lower side and the limit on the upper side. And any value that is crossing the limit, either on the upper side, which is like a 3 IQRs above the Q3 or 3 IQRs below the Q1. So if we are having any such kind of values which are in the outside of the limits, we will treat them as outliers and we can directly remove them. Or not remove, we'll handle them, right? So that is about the box plot. Then we are also coming to the scatter plot. So this is purely between two numerical columns, right? So both will use the horizontal and the vertical axis, and it's a line plot. But the only difference is in the line plot, we have time related angle on the x-axis, time or date related variable on the x-axis. Whereas in a scatter plot, that is not the case. We are trying to understand the relationship between two numerical variables, not necessarily a date or a time variable. So probably the correlation, by how much extent a change in one variable can impact the other variable. That is what we are trying to understand in a scatter plot. So the association or a relationship, obviously here, this plot will actually tell you what is the relationship between x and y. As x increases, what is expected regarding the value of y? Is it going to go up or go flat or something? So if some association exists, then possibly you will see that the clustering could happen, right? Possibly you could see that the all the points are in a kind of 45-degree line to the y-axis, to the axis, or they are like the inverted 45-degree kind of a line. So what you will see is there will be some kind of direction, upward movement or downward movement you would typically observe when there is some kind of correlation between the variable. But if there is no correlation or no association between the variables, you will see almost like a flattened off kind of appear, right? So we can always see about the direction. If it is upward sloping, I say there is a positive correlation. If it is a downward sloping, then I can say there is a negative correlation, right? So depending on the positive or a negative sloping also, I can very well decide on the correlation aspect. And which means if there is a increase in one variable and the same is reflected in the other variable, then we simply say there is a positive correlation and a negative correlation. And obviously you all know that you can compute the value of that correlation by using a correlation function. We will be discussing all those things, right? Here we are only introducing all the various important modules that you would be covering in a data science activity. And okay, and even if the relationship is linear or non-linear also, you can very well make it. That's one advantage of the scatter plot. So you may very well see the relationship between x and y could be a U-shaped relationship, or it could be an inverted U-shaped relationship, or it could be a kind of a C-shaped relationship. You can very well understand whether the relationship between x and y is a linear relationship or some form of a non-linear relationship. And because of all these activities, it can also help me in terms of identifying pairwise outliers in the data. So possibly x and y are all concentrated on the lower half. Let's say most of the x and y's are like this, but suddenly I find one xy point here, or suddenly I find one xy point here. So in that case, these are typically called as pairwise outliers. Individually, when I look at based on, or possibly it might be here. So individually, when I look at x and y, they may or may not look like an outlier. But if I take combinedly x and y, it might very well come out as a kind of outlier. So those kind of interpretations are also very much possible. So you could see here, I have taken the data from 0 to 10 with an increment of 0.1. I have taken some function of x, some function of two different functions, y1 and y2. I am plotting a scatter plot, right? You could see that one of them is increasing, the other one is decreasing. So in our data also for the loan amount, I can very well do a scatter plot. So loan amount and the property value. Now you could see here, there is some kind of an upward sloping that I could see. On a broad note, I could see some kind of an upward slope, but we are not fully sure, right? Sometimes the correlation may not give me a bright picture, right? Though on a broad note, I mean, sometimes the scatter plot may not give me a brighter picture. It might just give me some kind of a base visualization. But definitely, when you compute the value of the correlation, it might definitely give you a much better picture, right? So these are some of the basic charts, but if you want to look at all the other kinds of charts, then you can see there is a violin plot, right? So just like a box plot, you can very well go for a violin plot. So let us see if at all, let's say I want to go for a violin plot. So just like a box plot, so this thing is violin plot. Now this is how the violin plot has come. Now how to interpret the violin plot and all, probably you may have to read through. But here also the violin plot also typically focuses just like a box plot, where it looks at the distribution of the data. But the way it looks at the distribution of the data is slightly different from the way the box plot looks like. Possibly you can do a kind of a little bit of exploration on the same. Possibly by doing a Googling, you will get a little bit of more clarity on what each of these plots are doing. But of course, I mean, whatever is explained by the box plot, the same thing is being explained by the violin plot as well. The only difference is a slight difference in the way it is presented, right? So we can explore on those aspects as well. Now, the next important thing that we require is if I want to customize. As we rightly looked at, the customizations could be with respect to the line, the color for the line, the weight, the ticks, where should the ticks come, where what should be the color of the line, or we can work out with the axis. So, so there are various parameters with respect to the axis. And someone was asking if I want to plot multiple plots in one single canvas. I have different variable values. So I want to plot all of them in one single chart. That is where we use the concept of subplots. And somewhere someone was also asking, how do I plot a big chart? So the figure size will help me in terms of deciding what should be the size of the chart, right? The figure, I can very well specify what should be the figure size. Then in some cases, I can also add the legends. What does the first bar talk of? What does the X values talk of, etc. So we'll go one by one. So if you want for looking at the colors, we have already talked about B, G, R, right? Possibly here I am doing a plotting between X and X squared, X and X to the power 2.5. x and x cube. So I'm plotting three graphs. So here, if you see here, I'm saying subplots. So when I'm using subplots, right? So there are two outputs that come out of the subplot. So when we are using the word subplot here, we are typically plotting in the same thing because we are using AX. We are using only AX as the plot. So which means AX dot plot, first it will plot x square with a blue color and a kind of a line with a blue color and a typical line, right? Because dash, 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 it will become a line. And similarly, if you are typical, so it's like dashes line. And similarly, if you are going with G, green color, two lines is more like dot dash, dash, dash. So it's like a dashed line. And possibly if I am simply, so blue line is typically with a line and, oh, okay, dot is also there. So line and a dot, both of them are there. So you could see here, the dots are there at every interval and there is a line. And possibly if you are talking about just the color, then it's like a smooth line. So first you specify your X value, then you specify your Y value, then you specify some of these, especially the color and the type of the line that you want to plot. So that's one thing that you can understand. Second, you can also talk about the figure and the axis. So you can add multiple axes here, right? This is one more aspect. So figure is basically, it is talking about your overall canvas. Figure is more like your overall canvas, right? So you want to create a new figure in that particular canvas. You want to create a sub figure in that particular canvas. And you are putting the axis values. So let's say in this particular area, how much width for the x-axis, how much width for the y-axis, and so on. So we'll try to understand something here. So let's say I'm saying x is the values taking 0, 1, 2, 3, 4, 5. Y is the square of x. Now, I will create one empty figure. So when I'm saying figure, it is typically an empty figure that is created. And on that figure, I'm adding two different axes, which means two different plots are going to come. What is that we are saying for these two different plots? One is, you see, there is a 0.1 unit from the left, then 0.1 unit from the left and bottom. So if you look at it here, axis 1, 0.1 unit from the left. So let's say from here the plot has started like this. 0.1 unit from the left and 0.1 unit from the bottom. And it is having a width of 0.8 units. So 0.1 to 0.9 is what it has plotted here. And similarly, it is having a height of 0.8 units. So left, bottom, width, height. So these are the four variables that are representing. Left, bottom, width, height. So possibly if you now see, I'm going with the axis. I'm adding one more axis. You just observe it. Left is 0.2. So from here, I just left 0.2. Okay, from the left. Then 0.4, 0.5 from the bottom. So it has actually come out like this, up to up. Then the width is 0.4. So possibly it is ending up at 0.6 itself. and the height is 0.3, which is like a 30, so 30%. So whatever is the area, so by specifying these things, we are clearly saying that we are defining the location of the chart. So if I want to put a chart inside a chart, I can even do a careful numbering of these values. I can very well put a chart inside a chart. And possibly now I know this is the I've added two different axes to the charts now. So axis one is containing the big chart. So for that I am doing a plot of x and y. And for a small chart, I am doing a plot of y and x. So y is my x value and x is the y value with the red color. So this is how I can create such kind of chart. So basically I can play around with figure and axis. So whatever are your figures, you will add the axis to those. So axis is the area on which the data is plotted with functions such as plot, scatter, whatever are the. So plot is for a line chart, scatter is for a scatter plot. You can very well have multiple such kind of chart. So this one is again a good visual representation, right? In some cases, you can also go with subplots, right? Not so here you could see it's like a figure in figure kind, picture in picture kind. Whereas here I am talking about subplots where I can specify the number of rows and number of columns. So I say initially I am defining subplots, 2 rows and 2 columns. So I will simply get something like this, right? If I'm going with the 2 rows and 2 columns, I'll simply get something like this. So which means I have 4 plots. Now, if I really want to plot, let's say here I'm saying subplot 2 comma 2 comma 1. So which means, so I know that I'm creating 2 subplots, right? I'm creating 2 subplots. Now when I'm doing a subplot, the first subplot, this is what is my first subplot. And possibly here I am also having my fourth subplot. In the first subplot, I'm simply saying x and x squared with a red color. So this is what is the plot. And similarly, in the fourth subplot, so second and the third, I am not specifying anything. So I'm saying again x and x squared with a green color, but a dashed one. So this is the one that is coming. So you can very well specify the multiple subplots also. With one single line of code, you can plot them. That's one more customization. Similarly, you can start exploring the limits. You can set the x-axis limits. You can set the y-axis limits. You can create a tight layout, right? Basically, automatically adjusting the position of the axis. You can try playing around. I think some basic things we have covered. Figure size, we have already talked about. If I want a bigger figure, right, not this size, I want a bigger figure size, then possibly I can go with the fixed size. Or another function that I can very well use is a legend function. And I can also do a saving of the configuration. I can very well save whatever is my figure. I say that save fig and I can give a file name to that. So it will typically save my this thing. So these are some of the things relating to the basic visualization and matplotlib. So I suggest I have already shared the sheet, or possibly I think you can still use the updated sheet because I have shared the Google sheet. So you can very well work on this. And in the next class, which happens to be on a Friday, we will work with the Seaborn, which is also another useful library. Possibly will get much more colorful and beautiful looking visualizations when you work with Seaborn. I have shared all the sheets till now. We do not have a class tomorrow. We have it on Saturday. Okay, I've shared the sheet, but again, let me share it again. I would put this in my all right. Okay. So let's again meet on Saturday. Thanks a lot, everyone. Yeah, you can. I mean, we still have CBON in this, so you can very well prepare for the CBON in advance, and possibly I'll even share the next one as well. Right, CBON is still there in the same sheet, so you can very well do the practice of the same. Okay, thanks a lot, everyone. I think you want the notes as well. Okay, so I'll share the notes as well. Thanks a lot, everyone, for listening to these sessions. Thank you very much. Take care. Bye bye.